Good morning everyone. In our last video, we have seen a ray diagram for a spherical lens, and today we are just applying that knowledge in this topic, which is the image formation by convex lens. As you know that for forming any image, we need at least two rays, right? Which ray? Their knowledge will be taken by the last, means a previous video. There is three rays. First, parallel to principal axis. Second one passing from the optical centers, and the third one passing from the principal focus. And from three of them, we have to use only two of the ray. The first one parallel to the principal axis, and the second one passing from optical center. As we have seen in a mirrors, in this one, the convex lens is the same as that of concave mirror. Means the image formed by a convex lens and the image formed by a concave mirror both are same. Just the difference is that the concave mirror uses a reflection for forming an image, while this convex lens uses a refraction for forming an image. So the images formed by both the objects are same in nature, size and position, right? Only the difference is reflection and the refraction, right? So for the convex lens also there is a sixth image which is formed by this lens, right? You have to put an object at a different distances and you get an image at different position with the different nature and the size. So first of all, where should we put an object? The position of an object. This object is at infinity, and as I have said in a mirror, if the object is infinity, we can see it, and just because of that, the two rays which are coming from that object is always parallel to the principal axis. So we have to take two rays. Both rays should be parallel to the principal axis, right? So here it is the two rays. First ray, and here it is second ray. Both rays are parallel to the principal axis, and as I have said that if the ray is parallel to the principal axis, after refraction it passes from the principal focus and it uses a refraction, right? It uses a refraction, not a reflection. So it just passes from the F to. Another ray is also parallel to the principal axis, so it will also passes from the F. Then where the image is formed, as I have said during the image formation of mirror, when two rays are made, during that time the image is formed. So according to it, this image is formed at F2, at where the two rays are just made on F2. So we have to take image, position of an image is on F, on principal focus. On principal focus F. I am not writing here F2 or F1 because if object is this side, then you get on F2, and another side, then you get F1. So we are just taking as a F, a principal focus F. What is the nature of an image? As you can see here, due to refraction, this ray made actually. So the image is real and inverted. Real image is always inverted, so it is inverted. And what is the size of an image? It is highly diminished. It is highly diminished, or you can say that point-like image. The image is just like a point, as we have seen in a concave mirror also, right? So this image is formed in F2, and it is real and the inverted, and it is highly diminished. Now, if I change the position of an object, okay? If I put an object on F, on principal focus. If the object is on F, then what happens? What is the position of an image? What type is it? And what is the size of that image? So we are going to form that. Okay. Now the object is on principal focus. You can put on F1 or F2, right? I am just putting on F1. So here it is object. I am giving a name A, B. For forming an image, how many points we need? Only one point, which is the head point, means A. And for forming image, we need two rays from the A. The first is parallel to the principal axis, as I have said in a previous lecture. The first ray should be parallel to the principal axis. And if it is parallel, then it is passes from the F to. What is the second ray? Second ray should be passes from O. Parallel ray, after reflection it passes from F2 and the passes from O. Will never reflect. You can see here both the rays are parallel to each other. If they are parallel, then you can say that they will meet at infinity distance. So the position of an image is at infinity. What is the nature? Nature is real and inverted. And size of an image is highly magnified. Right? Highly magnified. If they meet at here, the size is like that. If it go more far than length, then the size will becomes more. So you can say that it is highly magnified, right? So at here, if the object is on principal focus, you get an image at infinity, real and inverted, and highly magnified. Okay. Now the third. If I put an object beyond 12, beyond center of curvature to F. Object is beyond 2F. So you can put object beyond 2F, a diameter. If I put an object at here, if I give it a name A and B, then you have to incident a two rays from the A. The first is parallel to the principal axis. After refraction, it will passes from the F. and the second ray should be passes from O, optical cell. Second ray should be passes from O. And you get an image between F and 2F. At here A dash, at here B dash. Okay? If the object is beyond 2F, then you get an image in between F and 2F. So here it is our object. Position of an image is between F and 2F. What is the nature of an image? It is real. You can see it here. And inverted. And what is the size? Object is bigger as compared to image. Here it is the size of an object, and here it is size of an image. So you can say that the image is smaller than the object. So diminished. So the image is diminished. If the object is beyond center of curvature, you get an image between F and 2F, which is real and inverted, and the diminished, right? Just compare it with the image formation by concave mirror, then it is same as that, right? So just comparing it with the image formation by concave mirror also, okay? Just the difference is that image is formed due to refraction at here. So the image formed in the other side of the object, while in a concave mirror the image is formed in the side of an object because it is just formed because of the reflection. Okay. So now there is a 3 image formation. Now the 4th. If the object is in between F and 2F, what happens? So here it is our convex lens. Here it is principal axis, right? O is in between of both of them. Means at the center point of a convex lens. Then on the one center 2F2, on the other center 2F1. Both should be same. Then in between both of them F2 and F1, the same distance from the O. Now object is in between F and 2F, so here it is an object. I am giving a name A, B, and as I have said to you that for forming an image we need a one point A. The first ray is parallel to the principal axis. After refraction, it passes from the F to and the another ray should be passes from the O. So these rays are emitted here. So you can form an image like that. Just explain your principal axis and you get A dash, B dash. So your image is beyond 2F. So at here it is beyond 2F. What is the nature? It is real and inverted. And the size is magnified. Size is magnified. It is bigger than the object. So here it is our 4-image formation. When object is at infinity, you get an image on F. When object is on F, you get an image at infinity. When the object is beyond the 2F, you get between F and 2F. And when the object is between F and 2F, you get an image beyond the 2F. Now, our 5th image. On 2. If object is on 2, like when an object is on C. Here it is O. 2F2, 2F1. If your measurements are wrong, then you get a wrong image, right? Now, object is on 2. A, B. From A, you have to pass the 2 rays. First is parallel to the principal axis. After refraction, it passes from the principal focus. Now, our next ray passes from the optical center. So, they meet at a single point at where you get an which is on 2F. So, it's A dash. So whenever an object is on 2F, you get an image on 2F. So the position of an image is on 2F. The nature of an image is real and inverted. While the size is same as object. Same as the size of an object and the size of an image are same. When object is on 2F, you get an image on 2F. Same as when object is on a center of curvature C for the concave mirror. You get an image on C. Like that, at here also, you get an image on 2F. Now, our last image formed by convex lens. position is in between F and O. Principal focus and optical center. Convex lens, principal axis. Optical center. 2F2, 2F1, F1, F. Exactly the center of O and 2F2, F2. So now put an object on F and O. Right? So for forming an image, you need one point, and from that point A, you have to pass a two rays, one as a parallel to the principal axis. So here it is, which should be passes from F2. And the other ray is passes from O. As you can see, both the rays are diverging from each other. So, if you want to form an image with the divergent ray, you have to just extend it in a backward direction. So, at here, you have to extend it. Like that, at here also you have to extend, right? So both just meet at this point. You can see it here. The both the rays are just visually meet at here, right? So this image is known as A dash B dash, right? A dash B dash. This image is virtual, right? And the event. Now what is the position of an image? Position is on the same side of lens at where object is placed, right? Same side, you get an image on the same side at where the object is placed, right? Like that, the nature is it's erect and virtual. You can see it here. The image is virtual and it is erect, right? And what is the size? It is magnified. It is magnified. You can see this image, right? It is a magnified. So like that, with the help of convex lens, we get a 6 different type of image by the different position of an object for the convex lens, right? All of the image formation is same as that of concave mirror, right? The difference is reflection, not more than 8. So you can easily understand or easily remember all the images for the different position of an object by remembering it as the same as in a concave mirror, right? So here it is our image formation by convex lens. Okay, thank you.